Auzubillahiminash-shaytanir-rajeem. Bismillahir-Rahmanir-Rahim. Dear students, Assalamu alaikum. I am Dr. Azhar Ali, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar, and you welcome back to this study. Dear student, in this first video lecture of week 13 for the course Applied Mathematics 1, today we are going to learn about another techniques of integration which is called partial fraction. So in this video lecture today we are going to learn about integration by partial fraction. So first of all, I would like to tell you about the definition of partial fraction. Partial fraction, actually when we write a single fraction into sum of two or more fraction, this is called partial fraction. But dear students, note that there are two types of algebraic fraction. One is the proper fraction and other is improper fraction. So we can resolve only the proper fraction into partial fraction. Proper fraction is a fraction in which the degree of numerator is less than the degree of denominator. And improper fraction is that fraction in which degree of numerator is equal or greater than the degree of denominator. So actually when we have an algebraic expression in the form of p by q, then this will be called a fraction. P and q will be two functions. In this video lecture, actually we resolve the algebraic proper fraction into partial fraction. So suppose p of x is an algebraic function and q of x is another algebraic function. So when we write p function in x divided by q of x, where q of x does not equal to 0, then this will be called the fraction. And when the degree of p function is less than the degree of q function, then the fraction will be proper fraction. And if the degree of p function is equal or greater than the degree of q function, then the fraction will be called improper fraction. So we can only resolve the proper fraction into partial fraction. So this is the definition of partial fraction, to write a single proper fraction into sum of two or more proper fraction. This is called partial fraction. But when the fraction is improper, then first of all we will convert the improper fraction to the proper fraction. So how we can convert improper fraction into proper fraction? So first of all, divide the q function by divide the p function by q function and write the result of this division as polynomial plus proper fraction. So polynomial plus proper fraction is improper fraction is actually the sum of polynomial plus partial fraction. So dear students, in this video lecture, now first of all I would like to tell you about the definition of partial fraction again. Partial fraction decomposition has great value as a tool for integration. This process may be thought of as reverse of the aiding fractional algebraic expression, and it allows us to break up rational expression into simpler terms. Partial fraction decomposition is an algebraic procedure for expressing a reduced rational function as a sum of fractional parts
For example, a rational expression f of x is equal to p of x divided by d of x, where d of x does not equal to 0. If this denominator contain non-repeated linear factors, then the partial fraction can be written as p divided by x plus a1 into x plus a2 into and so on x plus an, which is equal to a divided by x plus a1 plus b divided by x plus a2 plus and so on mn divided by x plus an. So this is the partial fraction when we obtain the linear factor in the denominator. So dear student, first of all, note that in the algebraic function, when we obtain uh, two functions are in divide form, this will be the called algebraic rational function. And for the improper for the partial fraction, actually in the fraction we have two types. One is the proper fraction and other is the improper fraction. What is called proper fraction and improper fraction? In the proper fraction, the power of the denominator will be greater than the power of numerator. The product of the denominator will be greater than the power of numerator, then the fraction called proper fraction. So in case of partial fraction, we can convert the partial into partial fractions. And what is partial fraction? To write a single proper fraction into sum of two or more fractions is called partial fraction. So there are two types of fraction. One is the proper fraction and other is the improper fraction. Partial fraction is that fraction in which the degree of the denominator is greater than the degree of the numerator. So this is called the partial fraction. And we can convert the proper fraction into partial fractions. And what is partial fraction? Partial fraction actually mean to write a single proper fraction into sum of two or more proper fractions is called partial fractions of a proper fraction. And what is improper fraction? Improper fraction is a fraction in which the degree of the denominator is less than the degree of the numerator, and when the degree of denominator and numerator are same. In these two cases, the fraction is called improper fraction, and we cannot take the partials of improper fractions. So when the fraction is in the improper form, first of all we convert the improper fraction into the into the proper form, then we can take the partials of that proper fractions. And how we can convert the improper fraction into the proper fractions? By using the ordinary divisions. By using the division, we can convert the improper fraction into the proper fractions. Now, for example, we have a fraction x squared plus 4x plus 1 divided by x minus 1 into x plus 1 into x plus 3. And this fraction, dear student, you see over here, the degree of the denominator is greater than the degree of numerator. So, for this purpose, now the integration of this fraction, actually we have linear factors in the product form in the denominator. So first of all, write this single fraction into the sum of three fractions. Like you see over here, we can write a divided by x minus 1 plus b divided by x plus 1 plus c divided by x plus 3. Now a, b and c are unknown constant. So first of all, find these unknowns. For these unknown, using the cross multiplications, multiplying both side by x minus 1 into x plus 1 into x plus 3, we obtain x squared plus 4x plus 1 is equal to a into x plus 1 into x plus 3 plus b into x minus 1 into x plus 3 plus c into x minus 1 into x plus 1. Now this is equation number 2. Now in this equation, putting x is equal to 1, putting x is equal to minus 1 and putting x is equal to minus 3. First of all, suppose x plus 1 is equal to 0, and then suppose x plus 3 is equal to 0, and then suppose x minus 1 is equal to 0. We will obtain the constant a, b and c like you see over here. uh, for putting x is equal to 1, x is equal to minus 1, x is equal to minus 3. In this equation number 2, we obtain 1 minus 4 plus 1 is equal to b into b minus 2 into 2. So this implies that minus 2 into minus 4b. So this implies that b is equal to 1 over 2. And now for putting this term, uh, x minus 1 is equal to 0. This term will be 0, this term will be 0, and now we obtain 1 plus 4 plus 1 is equal to a into 2 into 2. This implies that 6 is equal to 4a, and now 3 by 2 is equal to a. Now, for putting this term will be equal to 0. Putting x plus 3 is equal to 0, mean x is equal to minus 3. A will be 0, b will be 0, and now for the c term, 9 minus 12 plus 1 is equal to c into minus 4 into minus 2, and this implies that minus 2 is equal to 8c, so c is equal to minus 1 over 4. Now putting the value of a, b and c in this equation number 2, we obtain x squared plus 4x plus 1 divided by x minus 1 into x plus 1 into x plus 3, which is equal to 3 divided by 2 into x minus 1 plus 1 over 2 into x plus 1 minus 1 over 4 into x plus 3. Now integrating both sides, we obtain like you see over here. So the integration of the left hand side and integration of the right hand side with respect to x. So by using the rule, since the derivative of the denominator is appear in the numerator, since the derivative of x minus 1 is equal to 1, and we obtain here 1 over x minus 1, so we can take natural log of x minus 1, and now in this second term the derivative of x plus 1 is 1, so we can take the natural log of x plus 1, and similarly the derivative of x plus 3 is equal to 1, so we take the natural log of x plus 3, and this is the result of the given problem. Now another example, integration of x plus 4 divided by x square plus 5x minus 6. Now in the denominator we have the quadratic function, so sometime we convert this quadratic function into the linear factor by using the sum and product factorization. So we can write x squared plus 5x minus 6 is x squared minus 3x minus 2x minus 6. So this implies that x plus 4 divided by x minus 2 into x minus 3. Now resolve this integral into partial fraction to solve this fraction into partial. So x plus 4 divided by x minus 2 into x minus 3, which can be written as a divided by x minus 2 plus b divided by x minus 3. Now multiplying both sides by x minus 2 into x minus 3, we obtain x plus 4 into a into x minus 3 plus b into x minus 2. So putting x is equal to x minus 2 is equal to 0, and putting x minus 3 is equal to 0, we obtain x is equal to 2 and x is equal to 3. And now putting x is equal to 2 and x is equal to 3 in equation number 2, we obtain putting x minus 2 is equal to 0, we obtain x is equal to 2. So 2 plus 4 in the left hand side, we obtain 2 plus 4 is equal to a into minus 1, and this implies that a is equal to minus 6. Now putting x minus 2 is equal to 0, so x is equal to 2, x minus 3 is equal to 0. So in the left hand side we obtain 3 plus 4 into b into minus 1, and this implies that b is equal to 7. Now putting the value of a and b in equation number 1, we obtain x plus 4 divided by x minus 2 into x minus 3, which is equal to 6 divided by x minus 2 plus 7 divided by x minus 3. So by taking integration, now we can write this is the integration of the left hand side, and integration of the right hand side is equal to 6 into 1 over x minus 2 with respect to x plus 7 integration of 1 over x minus 3 with respect to x. So the derivative of x minus 2 is 1, so natural log of x minus 2 will obtain the integration of this fraction, and the derivative of x minus 3 is equal to 1, so the integration of this fraction is equal to natural log of x minus 3 plus constant of integration. Now another problem, the integration of 1 over t cube plus t square minus 2t. Now this is the function. In this function the degree of denominator is greater than numerator, so this is the proper fraction. So we can resolve this into partial fraction by taking common t. We obtain t into t square plus t minus 2 from the denominator, and now t square plus t minus 2 is the quadratic function, so by using factorization sum and product we obtain t square plus 2t minus t minus 2, so 1 over t into t minus 1 into t plus 2. Now resolving this fraction into partial, so we can write, since in the denominator we obtain the linear factors, so we put a divided by t plus b divided by t minus 2 plus c divided by t plus 2. Now by cross multiplication, by multiplying both sides by t into t minus 1 into t plus 2, we obtain 1 is equal to a into t minus 1 into t plus 2 plus bt into t plus 2 plus ct into t minus 1. This is equation number 2. Now putting t is equal to 0 in the equation number 2, we obtain 1 is equal to a into minus 1 into 2, and t is equal to 0. This term will be 0, and t is equal to this term also will be 0. So we obtain a is equal to minus 1 over 2. Now t is equal to 1. This a term will be 0, this c term will be equal to 0, and we obtain 1 is equal to b into 1. So this implies that b dot 1 into 3, 3b is equal to 1, so b is equal to 1 over 3. Now for putting t is equal to minus 2, we obtain 1 is equal to c dot 2 into 1, 2c is equal to 1, so c is equal to 1 over 2. Now putting the value of a, b and c in equation number 1, we obtain 1 over t into t minus 1 into t plus 2 is equal to minus 1 divided by 2t plus 1 divided by 3 into t minus 1 plus 1 divided by 2 into t plus 1. So taking the integration on both sides, this is the integration of the left hand side and this is the given problem. So integration of 1 over t with respect to t, which is equal to natural log of t, because the derivative of t is equal to 1, and similarly the derivative of t minus 1 is equal to 1, so natural log of t minus 1. Now the derivative of t plus 1 is equal to 1, so the integration of 1 over t plus 2 with respect to t is equal to natural log of t plus 2, and this is plus c, constant of integration. So this is the process of integration by using the partial fraction. So the conclusion of this lecture, dear student, note that in this lecture, you have learned about the two techniques of integrations. One technique is called integration by parts, and other techniques is called integration by partial fraction. And integration by parts, I have already told you that we have two functions in the product form. So the two functions will be maybe product of polynomial and trigonometry, product of polynomial and exponential, and product of polynomial and logarithm, and product of exponential and trigonometric functions. So in all these cases, dear student, first of all, note which function should be considered as a first function and which function considered as a second function. Since in the integration by parts, in the on the first function we apply the derivative, and on the second function we apply the integration. So in the product of polynomial and trigonometric, consider polynomial as a first function, and similarly, the product of polynomial and exponential, consider the polynomial as a first function. And in case of the product of polynomial and logarithmic function, consider logarithmic function as a first function. Now, integration by partial fraction. Actually, for the why we use partial fraction, sometimes we obtain the factors in the product form in the denominator. So that's why we use the partial fraction. By partial fraction, we convert the product of these factors into the form of addition. So partial fraction mean to write a single proper fraction into sum of two or more fractions. When we write a fraction into sum of two or more fractions, it's mean that when we write a fraction into the form of sum, then the integration, we can evaluate the integration very easily. Now, this is the end of this segment. Thank you. Allah Hafiz.